So, welcome. Hello. Someone asked, I did a workshop today, about 3 hours or something of Kotlin and functional stuff in Kotlin, and someone asked me afterwards, they said, is Java going to die? And is it going to be replaced by Kotlin? And what do you think? Do you think Java's going to die? How many Java developers here? Are you witnessing your own death? No. No. Java is not going to die. And I could say as much as I want for Kotlin to replace Java, I actually don't. Like, really, I don't care whether Kotlin replaces Java or not. We make tools for Java and Kotlin. So at the end of the day, as long as you use a tool that we make for your language, you can use whatever you want. So the question is, why would I want to use Kotlin in 2021? How many of you have ever played with Kotlin? Okay, how many of you write Kotlin code? Right. So some of you have played with it, some of you have not. Why would I want to use Kotlin in 2021? Because back when Kotlin came out in 2010, which we announced it, well, we started working in 2010, and when we announced it, I think, in 2011, Java was at version 6 or 7, I think. There was no Lambdas. There was many things that Kotlin had that Java didn't. And especially for Android developers, it was great because it allowed them to do a bunch of things that they couldn't do because they were stuck on Java 6. They didn't have Java 8. So now fast forward to 2021, Java is at version, what version is it? 28 or 29? 17? 17? Yeah, and then you ask people like, what version of Java are you using? Oh, I'm still on Java 8. Yeah, my company doesn't upgrade. So we're thinking of going to Java, 11 in a few years from now, and Java is already at version 17, and they've got like a 6-month cadence now, right? Every 6 months there's a new version of Java, which is great. They're catching up with the JavaScript people, right? Every new day there's a new version of a framework, and Java's like, we want to be in that game too. So the question is, Java has advanced. It's got a lot of features now that Kotlin has, so why would I want to continue to work with Kotlin? Which is a fair question. But I'll rephrase it another way. If you've started to work with Kotlin, why do you want to go back to Java? At the end of the day, as I said, I don't mind what you do, right? The important thing is that you use IntelliJ, whatever you do. That's the important thing. So, and if you can use the ultimate version, even better. Like, I'm all for open source and that and the community stuff, but the ultimate's got really cool things. Okay. So I'm going to show you some things around. I mean, most of you here, I guess, know Kotlin. But I'm going to show you some things that we still have that are a little bit different and maybe make it attractive for you to work with, continue to work with Kotlin. One of those features, obviously, is the type inference, which is quite good in Kotlin. And we try and cut down boilerplate code. So one of the things that we do is try and infer the types that you're using a lot. Right? So I can write val abc equals string, and it's going to infer the type for me. Right? I don't need to explicitly put the type. Of course, I can explicitly define it, and then it will show me the type. There's also a feature in IntelliJ, which is called type hints, which I don't know if you've seen, but it shows you the type without you writing in the code. And I'll repeat again, why? Like, why? If you need explicit typing, use explicit typing. If you don't, why are you using the IDE? The only valid answer there is, well, my colleague needs explicit typing, I don't, so therefore I'll just use implicit typing, and then my colleague can turn on those switches. And then, of course, your colleague, when they're looking at the code, they're going to print it out on a piece of paper, and they're like, oops, I don't have my types. But we try and be very intelligent as we can with these things. And even like when you declare a function, you got to excuse my naming. I'm really bad at naming stuff. We have these single expression functions where, again, you infer the type as much as you can, right? So this type inference makes the code a little bit more concise without actually hurting that much the readability of it. We try and cut down, again, boilerplate code with other things, like with objects, where you have, in Kotlin you have classes, you have functions, you have top-level functions that can just be declared everywhere, and then you have objects which are singletons in the land of Java and the land of C# and whatever. In Kotlin you can just basically declare them as objects, and they come in useful whether you want to just host a bunch of properties, they could be constants or what have you, or you want to do something like implement an anonymous object. In Kotlin, you could do that by means of an anonymous class. You could do that by means of just an object and then implement the interface that you want. Now, data classes, again, is something that we have and we've had from very early on, which is similar to records in Java. Difference is that data classes has copy-clone methods, whereas with records you don't have that. We have the same kind of destructuring as well. So for instance, I could say, if I create a customer here, we don't have the new keyword, and I say A and B, and then I can do val name and email equals customer A, B. So that allows me to destructure each of these into their own properties. This is actually a problem. Well, you can even use underscore if you're not interested in that value. You got to be careful with something like destructuring, because if you add a new property to a class and you insert it in wherever you were, suddenly, if I add another property over here that I say, for instance, phone, and it's the same type, and I insert it over here, suddenly this becomes the wrong value. So you got to be careful where you use these. So we have the data classes, which basically give you the clone and all of those. Again, something that you have similar to Java. You have literals to define collections of values. We have smart casting. This is something that isn't available in Java. So here, well, it is and it isn't. So here, any is the top level class in Kotlin, and then if I say object is of type customer and I do object.email, it automatically casts it to customer. I don't need it to be explicit. Now in Java in 17, I believe, you now have instance of, so you can check if object is instance of, but you have to declare a temporary variable and then reference that variable in the block where you're using this, right? In this case, you wouldn't need to, right? And patterns, well, patterns, we don't have that kind of pattern matching that you have in something like Haskell, which is a shame, actually. It would be really nice to have pattern matching. I think at some point it will come. I don't know when, so I can't ever be wrong, because maybe it will come in 50 years or 2, we never know. It's nice pattern matching, but we have pattern matching in kind of like switch statement, which is the when. And one thing that is nice about Kotlin is that both the statements, both the if statement and the when statement, can be treated as an expression, right? So if I have, for instance, in this case, let's pass in a variable x of type int, and I can say when x is in 1 to 10, then you could do this kind of behavior y, right, equals 0, and then I could say y equals 20, else y equals 30, right? Now this is, you're basically creating a temporary variable for no other purpose than to just return the value, so you can just do something like that, right? And well, in this case I don't even need the y, I could just say, well, val y equals, and then the actual value. And this is something that is very much encouraged in Kotlin, to try and treat everything as an expression. If you treat everything as an expression, then you're kind of assuming that it doesn't really have any side effects, it's just going to return a value, and that's how you kind of try and work, right? Same with functions. So this applies for when and if statements as well. Okay? So now let's go and see some other stuff that is a little bit more particular to Kotlin and still remains particular to Kotlin. And for folks that aren't familiar with higher level functions, let me just quickly show you the syntax. So I have an int and then returns an int, and that's a higher order function, not higher level. Higher order function, because it takes a function, or a function that returns a function is a higher order function. And then I can basically pass anything to this that matches that signature. So I have this function sum, which is a Java function, and I can actually pass it to it, right? Or I can create my own sum, x int y int equals x plus y. Okay? And the lambdas in Kotlin are defined in a very succinct way. So x plus y. In Kotlin, you can take this, and if the lambda is the last parameter to a function, you can put it outside of the brackets. And what you can also do is, if it's the only parameter to a function, you can remove the redundant brackets. If you've ever done Ruby, this is similar to Ruby. And then you could take it to the next level and make this multi-line, right? Which now makes higher order, if I were to rename higher order to, for instance, it feels like it's part of the language. And that's one of the keys to Kotlin. Very small surface area. Everything is defined as a function. Literally, like everything is defined as a function. There's very little in Kotlin that is actually part of the Kotlin language itself. Even when you're doing asynchronous programming, async, await, all of these are defined as functions. And this is kind of useful because it allows us to do a bunch of other things. So one of these things is DSLs, which we'll get to. But before to get to DSLs, let me show you another thing that is unique to Kotlin. If I have a variable here that is a equals abc, and I want to do is same as, I can create a function which is a and b, and over here I'll do a b, right? And this is basically create a function which is going to return a equals b. Okay? Now, if I want that to be part of the string, I would have to overwrite the string type. Or I could just create an extension to string, which basically you put the type, and then you put the name of the function you want to extend. So in this case, I would say that this, which is the instance, is equal to the parameter. And then now I could just do a is equal to b, right? Okay? The same as, what's the error here? Is samey. Let's call it is samey. Is samey. Val a abc and val b equals abc. Okay? Is same me. Okay? So that is basically an extension function, and I've just taken the type and extended it, whether it's a Java type or a Kotlin type. And this is very useful, and the standard library is built up of a lot of these extensions. And then I could go one step further and say, for example, ABC is samey as ABC, and all I need to do is add this infix modifier to my function, right? So this gives me this fluency that is not really available in some other languages. The closest you would probably come is something like Groovy, which is static, which is dynamically typed, and Ruby, which is also dynamically typed. So what does this allow me to do? If I have this concept of higher order functions, and then I have these concepts of infix functions and the way that I can declare them, I can start to combine these things and then go and create my little DSLs. So let's delete all of this rubbish over here, and let's go ahead and create a DSL, right? So I have this DSL. Basically what I want to do, DSL is a domain-specific language, right? So for folks that don't know what a domain-specific language is, it's a language that is specific to a particular domain. Understand? Yes. So it's essentially a way for you to create one language inside a language. Well, there's external DSLs and there's internal DSLs. And the benefit basically of it is that try to get your code to reflect as close as possible to the actual domain that you're trying to solve. Because the closer the language is to the domain, the easier it is for you to understand and the easier it is for other people to understand. And if one of the things that has always held us back from using DSLs, which have been around for many, many years, is the fluency that the languages provide. It's not great. The closest we've been able to get is with something like builders or fluent APIs where you have, dot, 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 and basically you're just chaining a whole bunch of things. So with Kotlin, you can try and get to that close encounter with your APIs. So let's say that I have, for instance, I want to create a cloud configuration. And my cloud configuration, for instance, has a server that has an address. And then I have a port, for instance, 90. And then it has a bunch of machines. And each machine has a CPU of like 30. Right? And I want to create this kind of DSL to define my configuration. Now this could be, in this case, it's how to deploy my application, but think, for instance, business logic. Think, for instance, defining your rules and process in your business application. I could use the same approach. So how do I go about doing this? And I always say that you really do not need to know Kotlin. To do this, you do not need to know Kotlin. All you need to do is one thing, Alt-Enter. That's it, okay? With Alt-Enter, you can do anything. And if IntelliJ suggests something, don't ask questions. Just say, okay. That's a joke. Do ask questions. I'll tell you a funny story. We have another tool called Resharper. Anybody heard about Resharper? Right. Resharper is like it's like the IntelliJ for Visual Studio before we had Rider, which is our .NET IDE. And Eric Meyer, who is one of the guys behind RxJava, was also one of the guys behind C#. And he introduced functional programming to C#. Although he didn't call it functional programming, he called it LINQ, L-I-N-Q. Language integrated query, because he said, if I call it functional programming, people will run away. Let me call it LINQ. And then what LINQ did, you could write your functions in a functional way. You could write your functions in a functional way. You could write your code in a more functional way. So what we did with Resharper is we took blocks of code and we introduced this feature, which was Alt-Enter. And what it would do is it would take your existing code and convert it into a more functional one. And people just went crazy. They were just taking these code bases and hitting Alt-Enter and then creating code that they didn't even understand, right? And seriously, it was like really bad because everyone was just saying, oh, look, Resharper is suggesting this. Let me press Alt-Enter. So in the next version of Resharper, we introduced a functionality that would take your functional programming and convert it back to imperative. So don't press Alt-Enter just because it's there. Anyway, here we want to press Alt-Enter. So what do I want to do? I want to create this code, okay? How do I create this code? I'm going to drive out how this would be created. I'm going to hit Alt-Enter, and it says, do you want to create a function? I'll say, okay, yes. Why? Because remember that I said that you can create a function and then you can have this multi-line lambda? That's what we're doing here. This looks like a function with a multi-line lambda. So I'm going to create a function, and now the question is, what do I pass into this function? So what do I have here? I have a bunch of properties, right? So what I could do is say, okay, well, I want to pass in a property which is called, let's say, cloud configuration, right? A class which is cloud configuration. And let me go ahead and create this cloud configuration. So I'll do class, cloud configuration, and then this is going to have a bunch of properties. So I'll have, for instance, server of type string, var port of type int, and then var machine of type machine. Okay? And this is also a class itself, which is of type machine, and this is going to have two properties, well, one property in this case, which is CPU of type int. Okay? So you say, well, what bloody good is that? It's still red. Now look at this it. This is one of those type hints that I was talking about. And there is a convention in Kotlin, similar to Groovy, in that if your Lambda has a single parameter, you can reference that parameter with a it. So instead of me writing something like x and then prefixing each of these with x, which will work, I could just basically just write it, right? It. Okay? And this one, machines, machine, did I spell it wrong? Okay, let's not worry about that for now. We'll get to that in a second. Okay, that works. Okay, that works. It's nice and it works, but the problem is the it. The it is horrible, and that's not what I was intending to do. So how do we get rid of that? I showed you how to do an extension function in Kotlin, right? And this is unique to Kotlin. So if I can do an extension function, and a higher order function is a function that takes a function, instead of passing in a function, I can pass in an extension function. How do I say that I'm passing in an extension function? Same way that I declare extension function. I say the type and then the parameters. In this case, there are no parameters. And voila, I now have my extension function being passed in. This is what's called a Lambda with receiver, okay? Because it's a Lambda that is receiving some object. Now let's go to the next step and we'll do machines. Now the problem here is what? Machines is, what is machines? What is it? A class. It's a property, right? So how do I do that? Because I'm trying to treat it as a Lambda. If I create a function, it's not going to really work, is it? Right? Because I'm saying that this is a property, machines, which in turn also has its own property, right? That was the problem there. It has its own property. So I can't now invoke it as a class, right? So how can I try and solve this problem? Well, there's a functionality in Kotlin which allows you to invoke an object, an instance of a type, as if it were a function. And you do that with the operator, which is invoke, right? Invoke, and then here you pass in the parameters for that operator, which in my case would be what? It would be a function, which is again a machine. It's an extension function to machine, right? Okay? So if I have this extension function to machine, now, we didn't need equals. Now I can invoke it, that property, as if it were a function, and then access its properties itself. And you can take this to any level you want. Now the good thing about this is what? I'm now creating a DSL that is expressive, that shows me what exactly it is doing, but I'm also getting a bunch of benefits from it, because if I want to refactor, I can refactor, and it will refactor everything. And when I type, when I come here and I press completion, it gives me all of the properties that I have. And if I go inside machines and I type completion, ooh, there's a problem. It gives me all of the properties that I have, and yet there I don't need it. Right? And this is an issue because while it's great, I could lead to incorrect code, because I can say, well, server equals whatever to whatever, right? So now I'm redefining the value of server twice. Server actually doesn't belong in this place. It belongs somewhere else. But we have annotations for that which allow you to restrict certain things, which are called DSL markers. And then, well, it wouldn't be here. You can use certain annotations that allow you to restrict what can be placed where. However, it's not that powerful in that you can restrict all things, but to a certain level, you can. But the point being here is that I can take Kotlin and the functions and extend that to create my DSLs in my application. Okay? Now, Kotlin comes with a bunch of other features, like, for example, if you take a look at the standard library, if we go, for instance, to val, let's say I have a list of numbers, and then I say lists first. Let's take a look at first. Okay? That's a property. And we could do, for instance, first. What is that? That is an extension function on iterable of t. So the majority of the stuff that is part of the standard library is basically extension functions to existing types. Now, once you go through the standard library, you start to see certain things in Kotlin and certain keywords such as inline. Okay? Inline essentially is the idea that it takes a function and it inlines it, which means it copy-pastes the code, which means that when I call a function with inline, it's as if there is no call stack. It's basically copying and pasting the code. So if I have a function here that's called ABC, and I return 0, I can say inline that function. And that means that every time I call ABC, there isn't ever going to be a call stack for ABC. It's going to copy the code in place. Now, if you ever do that in Kotlin, it's going to give you a warning. And the warning is that why are you doing this, essentially? Why are you inlining? Because there isn't any performance benefits of you doing that inlining. And that is true, because inlining only makes sense in Kotlin when you're talking about higher order functions. So this would only make sense if I had another parameter or a parameter which was a higher order function or another function, right? It was a higher order function because it took another function. Now inlining does make sense. That's where there is actually a good performance increase. Okay? And this, however, introduces a restriction in that I can only ever invoke the function that's being passed in. So I could do f of 1, but I couldn't do a equals f, because there is no such thing f, because it's being inlined, right? So that's okay. What happens if I have, for instance, a g, and the g I want to keep an instance of? What happens if I want to have, like, for example, x equals g, or not x, z equals g? I can add the reverse of inline, which is no inline. And no inline says, yeah? Well, you thought I was going to say don't inline, no? So no inline, what it does, it says, what does it do? It doesn't inline. Okay? So that means that now I can hold the reference to it. And if I have two no inlines, what's the compiler going to do? Say, then why the hell do you have an inline? If you don't want me to inline anything, why are you having an inline? Right? There's another one, which is called cross-inline. Anybody know what that does? Huh? Both, no? It does a little bit of this and a little bit of that. No. That is actually not what cross-inline does. Cross-inline is the way that... so functions, the return values from a lambdas, when you do a return from a lambda, it's called a local or non-local return, right? You have there's this concept of a local return and a non-local return. So if you have a function, and then inside that function you have a lambda, when you return from that lambda, it's a non-local return, right? So you can actually do a local return, which is using a label, say like return at the name of the function, and then it returns to that. So cross-inline is essentially a keyword that says don't allow lambdas that have local returns in these cases. Okay? Yes? It's similar to a break, yes. It's kind of like the local returns is kind of like a break with labels, yeah. So this inlining, again, allows you to do certain things like, increase the performance of your applications in terms of eliminating call stacks when you're doing a lot of code that has a lot of functions, which is one of the benefits of Kotlin, right? So Kotlin, again, I've repeated this a million times, but if you are a functional programmer, then Kotlin is ideal for you, because Kotlin is a functional programming language that also has some object orientation constructs. If, on the other hand, you're an object-oriented programmer, then Kotlin is ideal for you, because Kotlin is an object-oriented programming language with some functional constructs. Okay? But it is actually true, because it treats everything as a first-class citizen. If you ask someone what is a functional programming language, many people will say to you Haskell. That's it. Other than Haskell, there is no other functional programming language. Some, the 5 or 6 people in the world that do F# will say, well, F# is also a functional programming language. Now, if you ask a person that, for example, has created Haskell, contributed to the creation of Haskell, such as Eric Meyer, he'll say to you, a functional language is anything that treats functions as first-class citizens. And Kotlin, Scala, many of these languages treat functions as first-class citizens. There is no ceremony around creating a function. You can just create top-level functions. You don't need to create the object and inside the object create the function. So then this gives you a world of benefits, also makes you think about why the hell do I need all of these objects? And this is one of the important things that, when you finish this talk, some of you may say, okay, well, Kotlin was interesting. I'm going to look into it. Others will say, well, this was crap, and I don't like this talk. But it's not because of me, it's because of the content, the Kotlin. I mean, my talks are amazing. Normally it's the content that's bad. That doesn't even make sense. Anyway, but the important thing to understand is that you should always try and pick up a new language, because the new language allows you to look at different ways to solve the same problem. If you're always using the same language, you always try and solve the problems the same way. And it may be okay. You may be an expert and always have found the best way, but sometimes it may not be the case and you might discover something new. Okay, so nullability. That's something that people still love about Kotlin, right? Nullability is the thing. When I ask people, why do you use Kotlin? A lot of people say nullability is built into the language. And nullability essentially means that by default things cannot be null. Right? In Kotlin, when you declare a variable, you can't assign null to it. I can't come here and do null, because you have to be explicit. You have to say this is string that is nullable, and then I can assign null to it. It would be ideal if we didn't even have to have nullable types, but we do have nullable types primarily because Kotlin wants to interop with Java. So if you want to interop with Java, you need to have nullable types. And the most cases where you want to create nullable types is when you have to interop with Java. Generally, if you're writing new Kotlin code, you shouldn't be using nullable types. Nullable types is the lazy way of saying I don't want to deal with the non-happy path. It's essentially that. Because if you look through a lot of the code bases, there's a lot of if something is not null, do something. And the else is kind of like, what else? Why should I have an else? We don't need an else. It's never going to go there, right? So you get a lot of that code, and it even becomes more apparent because when people are interopting with Java, writing Kotlin code, you could do things like this, right? You can say, if some value is not null, then call the function on that value. So I don't have to do an if. I could just use the safe operator and say, if it's not null, call that function. But what you encounter a lot is people doing something like that in their code base, right? And what is that double hashbang? That double hashbang means I don't care if it's null. I mean, in my happy world where I live, this is never going to be null, so always invoke this function. And then what happens is that when they run their application, they get a null pointer exception, and they start screaming and saying, Kotlin promised me no nulls, and look at this, I've got nulls. This is something you should never use, right? It's kind of like there, but you should never use it, right? It's, if you have to use it, try and cut down. And if you're not using it, don't start. Kind of like smoking, right? Or COM. For those people that remember COM back in the old days? No, Windows COM? Okay, I'm looking at some of the audience, I'm like, you weren't even born when COM was around. God, I'm old. Right. COM was a way to communicate objects on the Windows platform. And then they made it easier for us, or they screwed us even more with DCOM, which was distributed COM, as if COM wasn't bad enough. And I had a friend that always used to say, COM is like smoking. If you're using it, stop. And if you haven't started using it, don't. It was in the Java days. You're familiar with Corba, right? You've heard of Corba, no? Basic. Have you heard of Basic programming language? Yeah. Yeah. Okay. Good. So I'm not that old. Okay. Now, one thing I want to talk about, which is again somewhat unique to Kotlin, is the concept of a plugin. So the compiler comes with this plugin architecture, which enables many, many wonderful things. It essentially means that I can override how the compiler works to a certain extent and change some behaviors, right? So if you do any kind of Spring, who does Spring here? Right. So Spring, for instance, has this idea of dependency injection built in, and you need to be able to inherit from classes or etc., right? Now in Kotlin, if you're not familiar with this, let me show you something quickly. No, not basics there. Let's go over here on a class. So let's say that I have a class person, okay? And I have an employee. And now I say, well, employee is a person. And this gives me an error. Does anybody know why? It's not open. Yes, it's not open. Someone once said, because employees are resources and not people. So, it's not open, right? Because by default, classes in Kotlin are final. So you need to be explicit about a class that you want to be able to inherit from. So coming back to where we were, which is the plugins, Spring has this plugin which is called All Open, which essentially avoids you having to write open everywhere in your classes. And for classes that have a specific annotation in Spring, could interpret that class for their purposes as open. And this is done by a plugin, right, that's available for Gradle and Maven, etc. And if you open up the build.gradle file, you can see that there's another plugin, for instance, which is called plugin Serialization. And that's how we provide serialization support in Kotlin. So you can see that I have this encode to string, and this is provided through the plugin, and it allows me to serialize things to JSON, to protocol buffers, to XML, to a different variety of stuff, right? And this plugin is also what is being used by, if anybody does here Android, Jetpack Compose. Yes, that's how they're doing the Compose as well, which allows it to be very performant. And then at JetBrains, we don't do Android development. So we've created Compose for desktop and Compose for web, which is the same idea of Compose, but allowing for desktop applications. Because contrary to what people think, the desktop is not dead, okay? This idea that, and by the way the web is going, which like literally, I don't know if you've noticed ever, that you open up the web on your website, on your phone, and you spend more time saying no, block location, get rid of this cookie warning, I don't want to subscribe, all of this, than actually you spend time on the app. So let's bring back the desktop. I say death to the web, because if we kill the web, we'll kill JavaScript as a side effect as well. Node.js, that was a mistake that shouldn't have happened. So one other thing that is in Kotlin right now, which is still experimental, but it's going to stay, and it's going to be improved drastically, is the concept of contracts. Are you familiar with contracts? Code contracts? This was something that C# brought. A few people looked at it, and Microsoft killed it. I don't know why. I think it was actually very nice. So here's an example of a contract. And essentially what I'm doing here is I've created a function which is an extension function of is null or empty. And I'm saying that this function needs to abide with a specific contract, which is that it should return false if this is not null or empty. So this is kind of telling the compiler at compile time that I'm guaranteeing you that this is going to be null or empty. And if it is not null or empty, I'm going to return false. If it is null or empty, I will return true. This allows the compiler to now infer information about that. And you can see in this case it's doing it by using this smartcast. Just as I showed you the smartcast of the object as customer, here it's doing the same thing. It's saying I can smartcast this to a not nullable type because I know that the contract is going to be met, right? You have other types of contracts here. For instance, if I were to take this code, this isn't going to compile, right? Because this is a val and it's initialized. It should be initialized just, before reading it. But this closure is basically going to it's not going to guarantee that this isn't going to be initialized more than once because it doesn't know how many times that might be called. So I can add a contract and say, well, I guarantee that this piece of code is only going to be called once, right? And then this is just that the error isn't, this is just IntelliJ being stupid. It should disappear. Seriously, it should disappear. There you go. You didn't see that bug, nor did I. So what that says is that this call is only going to happen once, right? If I go to the invocation kind, I can see exactly once, at least once, at most once, unknown. And then there, now this contract is being abided. So what is the purpose of this? The purpose of this is if I can guarantee that code is correct at compile time, even better. I mean, there's this saying with Haskell that they say that with Haskell, if the code compiles, you know that your application is correct. Because there's so much restriction in compile time in the correctness of the code that generally you probably won't run into runtime errors. And a lot of that is based on contracts, right? The idea of contracts or code contracts. So we are going to invest heavily in this. It's the same ideas, the same principles, although the syntax is going to change. It's going to be basically defined at the function declaration level. But for that to happen, for it to be efficient and well done, we need the new front end intermediate representation, or otherwise known as FIR, which we're working on. So approximately about 2 years, right? But I think it's interesting for you to start looking at the code contracts and understanding them because they are quite cool. And then, of course, another thing when you ask people like, what do you like about Kotlin, is the concepts of coroutines. So coroutines are essentially like lightweight threads. If I run this code, you can see basically what happens is that I get hello world. And what I'm doing is essentially I'm launching this block of code as a coroutine, and then I'm writing print line. So when the app runs from top to down, it's going to print first hello, and then it's going to print world. Why? Because although this is executed first, there's a delay of 1,000. So hello gets printed before the world. What this is essentially launching a new coroutine. And a coroutine is, think of it as a lightweight thread. So it's essentially a state machine where you have these functions which are suspendable. They have the keyword suspend, which means a function can be suspended and then resumed. Under the covers, the compiler is essentially creating a state machine saying, okay, this function is going to be suspended, and then when it resumes, it goes to this state, and so on and so forth. So it's not creating like this a thread every time you launch a coroutine. It actually can reuse threads. In fact, here you can see that I'm going to launch 100,000 coroutines and delay for 5 seconds and print a dot. And if I run this, you can try and run this with threads and you'll be waiting quite a bit. in our case, it's finished, right? It's just watch, it's just scrolled a lot here. So if I take the scroll bar all the way back here, you see that it's finished. Until recent versions of Mac OS, this wouldn't actually run. You would get out of memory exception. With recent versions, what it does is it actually delays creation of threads until it has enough memory. So it will run, but it'll just run very, very, very slow, right? And I was just talking to one of the folks from, where are you? I can't see you. Oh, not here. That they had some performance issues at ING, and they switched to coroutines, and magically all disappeared. Not the code, the thing. And coroutines follow this concept of structures concurrency, which basically means that if I have a coroutine and then that coroutine launches another coroutine, it's in the context of that coroutine. But the idea with coroutines is that I continue to write imperative top-down code and not worry about the whole changing the asynchronous model, changing to a different asynchronous model, changing to a different programming model when I want to do asynchronous programming. Okay? So, now let's go back to one of the things about Kotlin as an overall language. Again, I asked the other day, why are you still using Kotlin on Twitter? And I got a bunch of wonderful replies. One of them, the best one that I like, someone said, because I watched your talks, which is awesome, right? The other one was, one person said that Kotlin, the only reason that Kotlin was born was because Google needed an alternative to Java. Which is kind of funny, right? Because first of all, Google didn't create Kotlin. Second of all, yeah, there is no second of all. Google didn't create Kotlin. We created Kotlin back into, I mean JetBrains. I work for JetBrains. We sell IntelliJ. By the way, if you want a license, ask me later. I mean, if you pay for it, not. So I'm joking. This was great because back in 2017, Kotlin, Google said that Kotlin is now officially supported for Android development. And then a year or two later, Google said, okay, now we're just Kotlin for Android, right? If you want Java, yeah, we'll still support Java, but now it's just Kotlin. I'm not Google. I don't know if they're going to continue to support Java or not. I don't know. I can tell you one thing, though. Back in, when was it, in 2010 or so, when Google announced Android Studio being built on the IntelliJ platform. Do you remember that? Yeah? Well, they announced it, and at the conference, and they said, we'll continue to support Eclipse. Make your own conclusions. So I'm sure that they'll continue to support Java. I mean, Java is heavily used inside Google. But anyway, enough about Google. The point was that suddenly Kotlin became synonym with Android. And it's like, yeah, Kotlin, yeah, isn't that for Android? No, it's not. It bloody well isn't. Like, we didn't even do Android development back then. And now everyone thinks that Kotlin is Android, but Kotlin is more than Android. Kotlin is actually a multi-platform language that targets many platforms. So you can target JVM, you can target JavaScript, you can target native, which means you can target iOS, macOS, Linux, Windows, ARM, Raspberry Pi, many, many different things, right? And one of our goals here, and JavaScript, and WebAssembly, and one of our goals here is for you to be able to share code, right? The ultimate, thing that we all want as developers, right? Be able to share as much code as possible. Now, if we're talking, for instance, about mobile development, we change the approach. That it's a different approach to what other people do, in that we don't say write it once and pray for it to run everywhere. We say share code that is business logic, application logic, and then anything that is UI, delegate to this specific platform. So we interoperate with, obviously, Android, we interoperate with Swift, we interoperate with Objective-C, so you can create your UI using these libraries and then abstract as much code as you can away for the shared stuff. But when you have this scenario, you want to try and use as much common code as possible. So a typical application could become a project where you have common code, then you have maybe some JavaScript code, you have some JVM code, and you have some native code, right? Now the common code I could have, for instance, a data class. And the data class, is just your typical data class in Kotlin, which can be used from any of these platforms. And then I maybe have, for example, a log message, which I want to use in the common code, right? So I should be able to use my log message in common code. The problem is that log message may be a case that might differ based on the platform. If I'm running it on JVM, I may want to use, I don't know, SL4J. If I'm running it on iOS, I may want to use something different. How can I try and use this functionality in common code? How can I minimize the amount of code that I'm duplicating and take advantage of this? That is where this idea of expect and actual come in. So essentially what this is saying that when I use log message, you can expect that there's going to be a function called log message on the platform that you're targeting, right? So it's kind of like a header declaration. If you remember C, yeah? C had headers, and then you had to include, and then you could say, okay, there's a function here, and I'm going to be able to use it. It's similar to the same thing. And then if I come here and hit Alt-Enter, it says go to the actual declarations, and it shows me all of the declarations that I have for all of the different platforms. So if I go to JavaScript, it shows me console log, right? And if I come back here and say go to the JVM, you can see that I have the JVM implementation. And in fact, this is checked at compile time. So if I remove this and come back to my code here, it says that there's a missing implementation for the JVM, right? So this basically allows us to create these multi-platform projects that allow you in turn to essentially use Kotlin on different platforms, right? And there's people that have already there's some very large companies that have already put this multi-platform project in use for mobile development, but of course you can do it beyond mobile. You can do desktop, you can do JavaScript, what have you. And then if you're not into JavaScript and you want to do web development, we also have libraries and frameworks for that as well. So there's like a Kotlin Kotlin React, which allows you to use React for web development, but instead of writing Kotlin code, you're writing JavaScript. Instead of writing JavaScript, you're writing Kotlin code. If you're familiar with JavaScript and how they work, they use this. Well, if you're familiar with TypeScript, they use this thing called definitely type, which is basically headers for the different libraries. We make use of the same thing. The one issue I would say is that if you're a front-end developer, you probably don't care about the JVM and you probably don't care about Gradle, and that's one drawback. That with Kotlin, if you want to write Kotlin, you have to care about that. Right? We try and make it as transparent as possible, and we integrate with the build tools for JavaScript, but there is still this JVM and Gradle on your machine. Okay, so that's Kotlin in 2021. We're doing a whole bunch of other things. We're improving the performance. We're writing, as I said, a new front end. We're writing a new back end. Some of that back end is already done. We'll continue to invest in the language. And I think that, if you're trying to do comparisons between Java and Kotlin, you got to understand that you can't look at Kotlin today and look at Java today, because just as Java is progressing, Kotlin is also progressing, right? But at the end of the day, the important thing here is for you to use what you like. And many folks, when you ask them what you like about Kotlin, they say it's fun. They say, I enjoy writing Kotlin code. And we think that that's a stupid thing, but it's not, right? If you enjoy your job, you enjoy the tools that you use, you're going to be happier. And if you're happier, you're going to be more productive. And if you're more productive, it's going to be better for your company, right? Now, we all know that as developers. But you go to your manager and say, I want to be really happy. Can I write Kotlin code? And they'll say, I don't care if you're happy or not. Well, no, I mean, it depends on your manager. I come from Spain. We got nice managers there. But anyway, so for folks like that, you can, shoot them some, study and analysis that says that Kotlin is way more efficient than whatever other thing if you want to convince them. Like, have you ever gone to a conference and you go to buy a ticket and it's like, click here to find a letter that says, how do I convince my boss that I should go to this conference? Have you ever seen that? No? Like many conferences, like, create a template and send to your boss to convince them that you should go to this event. So we should do kind of something like that on Kotlin Lang, right? Create a letter to convince your boss to allow them to use Kotlin. So anyway, cool. Any questions? Okay. So how many of you are going to? This is. Please don't make me look bad. Okay. I mean, I counted the number of people that said that they've looked at Kotlin and the number of people that said they're writing Kotlin. Now, after my talk, how many are you going to look into Kotlin and maybe even write Kotlin? Ooh, by one. I convinced one more person. Well done. Pat yourself on the back. Well done. Good job, Hadi. You deserve a beer. Okay, thank you.